Alright, my little math friends, we are moving on. Now we're going to be looking at 11.2, and we're going to be comparing data from a box plot. Okay, now yesterday we looked at data from dot plots, and what dot plots show are actual data. Okay, we get to see what the numbers actually were because they're points on the dot plot. Alright, box plots show medians, a minimum, and a maximum. Okay, so on a box plot, we don't get to see what the data actually is. It's just a calculation of medians, a minimum, and a maximum. We get to see kind of what the data looks like, but not what it actually is. Okay, take a look at this first example. I'll show you what I mean. A high school basketball player played 12 games this season. Below is a box plot representing the number of points he scored each game. Okay, so here's the points he scored for all 12 games. We don't know exactly how many points he scored each game. This is just a spread of the data, the medians and the minimum and the maximum. Okay, for example, we know at least one game he scored 15 points because this is the minimum, and we know at least one of the games he scored 30 points because that's the maximum. All these other points in here are just medians, and we're going to talk about what those are. Okay, so it's not actual data that's shown, it's the medians. And what a box plot does is it breaks the data into 4 equal parts. Okay, it breaks the data into 4 equal parts, and because 4 goes with quarters, if we're looking at quarters, they call each part a quartile. Alright, and we'll talk about what that is here in a minute. So it breaks the data into 4 equal parts. What I mean by that is this basketball player played 12 games. Okay, so from here to here represents 3 of the games. From here to here represents 3 of the games. From this median up to here represents 3 games. And from here to here represents 3 games. Even though we don't know exactly what those scores are, it breaks the scores from all 12 games into 3 of the scores, 3 of the scores, 3 of the scores, and 3 more of the scores to get a total of the 12 games played. Okay, so that's what it does. It breaks the data into equal parts. And now let's take a look at what those different things are. So this middle one here is the exact median. Alright, and remember, we calculated that. We lined them up from, in a couple other lessons ago, we lined the data up from smallest to biggest and found the number in the middle. Okay, so that's what this shows in the box plot right there, is the median. Alright, and then we have the minimum and we have the maximum. And then what we have right here is our lower half of data. And this here is the lower median. Okay, or the lower middle. And over here on this side we have the upper half of the data. And this one right here is the upper median. And when you have a box plot, they have different names for each one of these sections. Okay, each one of these equal parts has a different name. This section right here is called the upper quartile. Okay, and then this section down here, this part is called the lower quartile. And then from the lower median to the upper median, this range right in here, we call that the interquartile. Okay, because it's kind of the inter part of the box plot. Okay, so there's our different parts of the box plot. We got a lot of stuff going on here that we just wrote down. So what are some observations we can make about this box plot? Okay, so what we can tell is we know the median is right here. So the median points he scored in a game was 21. So the median, we don't know if it was a he or a she. The median scored was 21 points. We can also see that the lower half of the points he scored were closer together. Okay, so let's go with that. Lower half of points were closer. And then we have this upper half of the points. These were more spread out. Okay, these points are more spread out. So we could say the upper half of points were further. Okay, further apart. So we got points that were closer together, points that were further apart. Okay, so that's what we can tell looking at this box plot. Now let's take a look at comparing two different box plots and see what we get. We're going to compare these two box plots both visually and numerically. So looking at it and with some numbers, here's what we have. The box plots show the distribution of the number of team wristbands sold daily by two different stores over the same time period. Okay, so let's say it was like a month. Alright, we have store A selling wristbands and store B selling wristbands. Okay, and we can tell just by looking at it. We don't know what the exact numbers of wristbands they sold, but we can see there's some differences between store A and store B. So first we want to describe the shape of each box plot. So store A, their data, the number of wristbands they sold, was more spread out. Okay, so we can put that down. That's what it looks like here. Data is more spread out. Okay, we can also see that most of their sales were down here in the lower. Okay, most sales were lower. Okay, store B, they had their data was closer together, and most of their sales were more than what we had for store A. Okay, so we can say data is closer and most sales were higher. Okay, I'm kind of shortening my writing here so that we get the point and that we're not spending a lot of time on the video writing more words than we need to get my point across here. Okay, so there's describing the shape of each box plot. Now let's compare the median, the upper median, and lower median of each box plot. So let's start with box A. We have a median of, and they don't tell us, exactly where it is. They don't give us a number there. We're just going to have to guesstimate. Let's call that about 43. Okay, so we could say the median is 43, and we'll just follow the order that it describes right here. Median 43, upper median 55, and lower median looks like about 31. Okay, now let's take a look at the medians for store B. Store B, we have 50. We could say our median here is 51. Our upper median is way up here at 65. And our lower median, we could call that about 47. Okay, so just looking at our medians, we can see some pretty big differences in the sales of these two stores. Alright, so what if we compare the minimum and the maximum of each box plot? So if for store A, we have a minimum of 25, a maximum of, looks like about 78. So 25 and 78. Alright, and then for store B, we got 42 and 74. Okay, so looking at that, store A definitely has a higher maximum and also a lower minimum compared to what store B has. So there's some comparisons. The last thing we're going to take a look at is comparing the range, which is the biggest minus the smallest. Okay, so let's take a look at that one first. Biggest minus the smallest, which we got those numbers right there. So we're going to take 78 minus 25 and see what we get for this one. So it looks like the range for store A is 53. When you subtract those two, 78 minus 25. And then store B, we're going to go 74 minus 42. Okay, and when we do the math on that, that gets us 32. Okay, so there's our range. Store A has a higher range than what store B is, and we can see that just by looking at it. The interquartile range is from here to here, the interquartiles, the actual interquartile parts. Okay, so we're going to go with this number and this number. So it looks like for store A, we are at 31 and 55. Okay, so if we subtract those two, 55 minus 31, we will get 24. Okay, so there's my interquartile range for this, 24. And if we're going to do the same thing with store B, looks like we have, that's going to get us 40, we'll say 47. And this could be, this is right here at 65. So then we could subtract those two. 65 minus 47, and that's going to get us 18. Okay, so we can see just by looking at that store A has a greater range, also a greater interquartile range. Store B has a smaller range and a smaller interquartile range, which is the same thing we made on these observations right up here just by looking at it. But now we have some numbers to kind of show how much different it actually is, because we can see the differences between all these numbers that we have here to represent these box plots. Okay, so that's how you compare box plots, just a general comparison. We're going to do some more of this next time in class. Don't forget to do the try this problem, and I'll see you guys next time, and we'll work some more of these out. Thank you for watching.